प्यारे बच्चों, आज हम पढ़ेंगे ऑर्बिटल वेलोसिटी के बारे में। क्या होती है ऑर्बिटल वेलोसिटी? इट इज द वेलोसिटी ऑफ ए बॉडी रिवॉल्विंग अराउंड अनदर बॉडी। अब क्योंकि हम सैटेलाइट की वेलोसिटी की बात करते हैं तो हम कुछ इस तरह से डिफाइन करते हैं। वेलोसिटी रिक्वायर्ड to put a satellite into its orbit। चलिए समझते हैं प्रिंसिपल ऑफ लॉन्चिंग ऑफ सैटेलाइट। ये हमने अर्थ शो की है। अर्थ के सरफेस के ऊपर ये टावर है, टॉल टावर। From here, suppose we throw a body with some horizontal velocity. Now, because the force of gravity is acting vertically downwards, due to combined effect of the two, the body will follow a parabolic path and will fall to the surface of Earth, say at point A1. Now, suppose we increase the horizontal velocity. This time again, the body will follow parabolic path and may hit the ground, say at point A2. The horizontal range has increased this time. If we further increase the horizontal velocity, body will again follow parabolic path, may hit the ground, say at point A3. So if we go on increasing horizontal velocity, a stage may come that the body misses the earth. It misses the surface of the earth. Now the body is in a state of free fall under gravity in an attempt to fall to the surface of the earth. Now the body will start orbiting around the surface of earth. चलिए फाइंड आउट करते हैं expression for orbital velocity of a satellite. Consider a satellite of mass m. This mass. Let this satellite is revolving around the earth at a height, say h. Then the radius of orbit of satellite will be equal to r plus h, where r is the radius of the earth. Let m is the mass of earth, and this mass is supposed to be concentrated at the center of the earth O. Well, we know that centripetal force is required to move a body along a circular path. So we write required centripetal force, or the centripetal force required by the satellite. This will be equal to m into v naught square over r, where v naught is orbital velocity of the satellite which we want to find out. R we have said is radius of the orbit, and radius of orbit is equal to r. Well, according to Newton's universal law of gravitation, force of gravitation between Earth and the satellite is given by F is equal to G is gravitational constant, m is the mass of earth which is supposed to be concentrated at center O. Small n mass of the satellite, and r is the radius of the orbit of the satellite. Well, because the centripetal force is provided by force of attraction between the earth and the satellite, therefore we can equate the two. Fc is equal to, must be equal to F. Fc we have written over R equal to from here we can find out the value of V0, orbital velocity. One R will cancel here. V0 is equal to 3 into m over r, its square root. Well, we know that acceleration due to gravity g is equal to gm over r square. gm फाइंड आउट कर लें और इस एक्सप्रेशन में सब्स्टिट्यूट कर दें. V0 is equal to g into r square over r. This is the expression for orbital velocity. Well, if the satellite is very close to the earth, उस केस में रेडियस ऑफ द ऑर्बिट r plus h which is equal to r can be considered to be approximately equal to r. h को इग्नोर कर सकते हैं, तो r की जगह उस केस में हम स्मॉल r की जगह r लगा लेते हैं. सो ये एक्सप्रेशन आ जाएगा ऑर्बिटल वेलोसिटी फॉर सैटेलाइट विच इज ऑर्बिटिंग क्लोज टू द सरफेस ऑफ अर्थ. तो इस केस में आ जाएगा g इंटू आर इट्स स्क्वायर रूट. V0 इज इक्वल टू g इंटू आर स्क्वायर रूट. चलिए अब फाइंड आउट करते हैं टाइम पीरियड ऑफ रेवोल्यूशन ऑफ द सैटेलाइट. We know that time period is the time taken to complete one revolution by the satellite. So, time period can be written as t is equal to distance travelled in one revolution over velocity. Distance is 2 pi into r divided by orbital velocity. So t कितना आ जाएगा 2 pi into r divided by orbital velocity is r into g over r its square root. तो ये आ जाएगा 2 pi over r into g into r. चलिए अब फाइंड आउट करते हैं एक्सप्रेशन फॉर आल्टीट्यूड और द एक्सप्रेशन फॉर हाइट ऑफ द सैटेलाइट अबव द सरफेस ऑफ अर्थ. उसके लिए हम क्या करते हैं, टाइम पीरियड के एक्सप्रेशन को वी नो दैट t इज इक्वल टू t is equal to 2 pi over over r. Let us spare both sides. You will get t square equal to 4 pi square over r square into r square into r over g. T square is equal to 4 pi square over r square into r cube over g. यहाँ से क्रॉस मल्टीप्लाई कर लेते हैं. t स्क्वेयर आर स्क्वेयर इंटू जी और इधर आ जाएगा 4 पाई स्क्वेयर इंटू आर क्यूब. यहाँ से आर क्यूब इज इक्वल टू टी स्क्वेयर आर स्क्वेयर इंटू जी ओवर 4 पाई स्क्वेयर. आर निकाल लेते हैं. आर की जगह हम लिख लेते हैं आर प्लस h. r plus h raised to power 3 equal to t square r square into g over 4 pi square. r plus h is equal to its cube root power 1 by 3. तो यहाँ से h is equal to this is the expression for height of a satellite above the surface of earth. चलिए अब बात करते हैं जियो स्टेशनरी सैटेलाइट की या जियो सिंक्रोनस सैटेलाइट. ये क्या होता है? It is a satellite which revolves around the earth in the same direction and with the same angular speed as that of the earth about its axis of rotation. Velocity of such a satellite with respect to the earth is 0. Means the geostationary satellite is a stationary with respect to earth. Well, time period of geostationary satellite is 24 hours. T is equal to 24 hours. अब इस एक्सप्रेशन में अगर हम 24 आवर्स t को सब्स्टिट्यूट करें 24 आवर्स इंटू 60 इंटू 60 सो मैनी सेकेंड्स. तो अगर ये वैल्यू सब्स्टिट्यूट करें h हमारे पास आ जाता है 35930 किलोमीटर्स अप्रॉक्सीमेटली 36,000 kilometers. Means the geostationary satellite is at a height of about 36,000 kilometers above the surface of earth. तो बच्चों क्वेश्चंस किस तरह से आते हैं इस टॉपिक में? Like what is orbital velocity? Derive expression for orbital velocity या फिर derive expression for time period of the revolution of the satellite or the height of the geostationary satellite above the surface of earth. Thank you.